Okay, number 19. This is just right triangle trig. Don't go doing anything weird here. This is my angle, so this is opposite, this is adjacent, which means this is tangent. So the tangent of 64 is equal to the opposite, which is 23, over the adjacent, which is x. Variables in the denominator, so they switch places. X is equal to 23 over the tangent of 64. I type that in my calculator, and I get that x is equal to 11.218. There are no units, so that's my answer. So number 20. Here's my angle. So this is the hypotenuse, this is the adjacent. That means that's cosine. So the cosine of theta is equal to the adjacent over the hypotenuse. I want theta, so I have to take the inverse to get it away from that. So theta is equal to the inverse cosine of 24 over 37. I type that in my calculator, and I get that theta is 49.560 degrees. So then here's my angle. This is my opposite. This is hypotenuse, so that is sine. Sine of 22 is opposite over hypotenuse. So that means I multiply both sides by the denominator. So x is equal to 19 times the sine of 22. So x is equal to 7.118. Right triangle trig. All right, so number 22, I'm going to have to draw and label a picture here. This says 30-foot ladder is leaning against an office building if the base of the ladder is 17 feet from the base of the ladder. Remember, that doesn't really make any sense, so this should say building. So here's my building, here's the ground, here's my ladder. So this is a 30-foot ladder. It is leaning against an office building. The ladder is 17 feet from the base, and I want to know what is this angle. So this is my hypotenuse, this is the adjacent. So that's going to be the cosine of theta is equal to the adjacent, which is 17, over the hypotenuse, which is 30. So take the cosine inverse. Theta is equal to the cosine inverse of 17 over 30. So theta is equal to 55.482 degrees. Sharon is bird watching and spots an eagle in a tree. When standing 40 meters from the base of the tree, the angle of elevation from the point in which she is standing is 37 degrees 27 minutes. After moving closer to the tree, Sharon now measures a 51 degree 42 minute angle of elevation. Determine the distance Sharon traveled between the viewings. Okay, so the first thing I want to do is change my angle measures here. So I'm going to take this 37 degrees 27 minutes, and I want to convert it to decimals so that I can actually use it. So I'm going to take this 27 and I'm going to divide it by 60, so I get 37.45 degrees. And then I'm going to take the 51 degrees 42 minutes and convert that. So I take that 42 and divide it by 60, and that's going to give me 51.7 degrees. Okay, so now I'm going to draw up my picture. Okay, so Sharon is bird watching. She spots an eagle in a tree. So there's my tree. So the eagle's up there somewhere. And when she's standing 40 meters from the base, the angle of elevation to the point at which she is standing, this right here, is 37.45 degrees. Then she's going to move closer. Now her angle of elevation is 51.7 degrees. And Determine the distance she traveled. So I'm looking for this. I'm going to call this x. All right, well, I know if this whole distance is 40, so if I knew what this was, I could subtract it from 40 and get my x. So I'm going to call this piece here y. And then let's think about what we can find. Well, here's what I know. I know this whole side of this triangle, and I know this angle. So I can find this side of my triangle. It doesn't ask me how far the eagle is from the ground, but I can find that. So if I find that using this big triangle here, I'm going to use this 40, this 37.45, and this right here. If I find all that, or use all that, I can find this. Then I can use this smaller triangle and find the y part that I need. So I'm kind of limited in this calculator to what I call things. Since I've already used x and y, I'll call this a because I can store it in a. So that means that, oh, I probably shouldn't use, I'll use the lowercase or the capital A because that's what's in the calculator. I don't want you to think it's adjacent. That could be confusing. So capital A, even though we're supposed to use lowercase. Because for this angle, this is the opposite side, this is the adjacent side. So that means I'm going to use tangent. So I'm going to take the tangent of 37.45. That's equal to the opposite, which is that capital A, so I can store it in my calculator, over the adjacent, which is 40. So that means the length A, which I'm going to store, is 40 times the tangent of 37.45. So remember on these calculators, what we're going to do then there is 40 times the tangent of, I lost my number, 37.45. And I'm going to get that number, and then I'm going to store that, so shift, recall, I'm going to store it in A. So I get A is 30.637, blah, blah, blah. So it's stored in there, and I know that A is equal to 30 something, right? So now that I have that, I can use this triangle here. I have this number, I have this angle, and I can find y. So it's tangent again. So it's the tangent of 51.7. That's equal to the opposite, which is A, which is stored in my calculator, over the adjacent, which I don't know, which is y. I'm looking for y, it's in the denominator, so y is equal to A divided by the tangent of 51.7. And that's exactly what I'm going to type in my calculator. Let's come back over here, and I can do recall A divided by the tangent of 51.7. And that gives me that angle. That is the y value, so I'm going to store that. Ooh, didn't mean to do that. So I'm not so sure that I just, let's see. I'm going to do A, let me do that again. Recall A divided by the tangent of 51.7. Okay, so that was the number that I had. I accidentally hit the wrong button. So I'm going to store that. So shift recall, and I'm going to store that in y because that's what I called it on my picture. So now that I have y, it's 24 something. Blah, blah, blah. What I want is 40 minus y, right? I'm looking for x. X is equal to 40 minus y. So if I do that, I can just do 40 minus recall y, and I get 15.804. So 15.8, I'm going to write down before I forget, 15.804. So in all this mess, I need to actually answer the question here. It says, determine the distance Sharon traveled. Okay, so I can say Sharon traveled 15.804 meters. There you go. You got to store and keep up with stuff and draw and label. Otherwise, you're going to get all kinds of confused about what is going on.